Yes, good evening, everyone. Am I audible? Okay, thank you, Vineet. Thank you. Okay, so welcome again in the next session. What we discussed in the last lecture, I want to know about that thing first from your side. Then after we can continue the session. What we discussed in the last session. Just tell me what we discussed in the last lecture so that I can come to know that what you studied, whether you remember something or not. Nobody is there to tell me. Tell me. Okay, no problem. So I'm just giving you the overview of the last session. That in last lecture we discussed about the electricity and electric current. So basically we discuss about the electric current, that how current flows, what are the responsible elements that flow the current in the circuit. So we discussed all about this thing in last lecture. So after knowing about the electric current, then we have the next topic, electric power. So what is electric power? How can we calculate in any of the circuit? We can study about here. So what is actually power? So if we want to write the standard definition of power, that is that is power is nothing but the rate of doing work. So if we are doing any task, so the rate of doing any task, any work which is assigned to you is the power. Okay. And it is also defined as rate of transfer of electrical energy. So basically in any of the circuit, what we are doing, we are transferring the electric energy from one place to another. So how much power is transferred from one place to another in given time, right? So that if we want to write it, that is per unit time. Per unit time, why? Because if we put the value time 1 second, then whatever the value of electrical energy transferred is the value of power. So whenever you write any definition, so we write per unit time. Unit time is 1 second. Okay. So if we put 1 second, then whatever the value of transferred energy is there will be used as electric power. Okay. So how can we know that thing? Just a minute. Please hold on. Okay. So this is the formula that is used to find the power. So we have already discussed about the current, that is I is equal to Q upon T. We discussed in the last session that what is current, how can we calculate the current. So current is the, this is the charge per unit time is current. So Q is charge. right? And T is time. You already know this thing, right? So this is the value of transferred energy. Okay, that is voltage into charge, and upon T is known as power. So this is the formula written by this definition. Okay, but we have already studied that I is equal to Q by T, so we can write this VQ upon T as V into Q upon T, like this. Okay, can we write this thing V into Q upon T, and Q upon T is nothing but the current. So we will replace this V by Q by T, Q by T by Y. So this formula, that is P is equal to VI, is basically used to calculate the power. Okay, if we have charge, voltage and time, then we can use this formula. If we have only voltage and current value, then we will use this formula. Okay, so depending upon the values that are given to you, can be used for calculating the power accordingly. So first we have to find out which value is given to us, right? After that we will try to find which formula will be calculated to find the power value. So that is V into I. So basically we use P is equal to VI formula for calculating the power, right? Further, we have studied V is equal to IR for from Ohm's law, right? So we can replace V by IR. So P is equal to V is written as IR into I is already there. So it will become I square R. So this is also another formula for calculating the power. And if we don't have current value, then from this formula, I can be written as V upon R. Okay, so we will put this value of I in this formula. So P is equal to V into I will be written as V upon R. So it will become V square upon R. So this is also one. So we have four formula: one, two, three, and four. So four formula are there that can be used to find the power, right? You can write somewhere this formula that is used for this. So these are the four formula that can be used for calculating power. I'll give you the question also, so you should write somewhere. Any problem in these formula if you have not understood anything? Any one of you? Have you understood all these formula? So you have to remember only one, right? That is V is equal to P is equal to VI. First formula should be written VQ upon T. This is the first formula. Second is P is equal to VI. So if you remember two, you can find remaining two also. So you will have completely four formula to calculate the power. Okay. So whenever we calculate anything, right? We calculated resistance, we calculated current. So there are units also. So similarly, the power has also one unit, and that unit is watt. So if after calculation power is 2, so 2 watt, that is watt. Clear? So we generally write W for this. 2 watt. So power is 2 watt. So whenever you calculate anything, there should be unit also along with the value. Clear? So what is watt? So 1 watt is right. So what will be 1 watt? That is the rate at which work is done when current is 1 ampere, which is flowing through a circuit with the electrical potential of power of voltage 1. Clear? So P is equal to VI. So whenever we put V1, I1, then power will be 1 watt. Right? So how could we got this value 1 after putting V1 and I1? So V is 1 volt and I is 1 ampere. So after putting V and I one value, we got P is equal to 1. What 1? 1 watt. So this is the definition of 1 watt. That is the rate at which work is done. It is already understood from the previous definition. But how could we get this value 1 watt? That is when current is 1 ampere and voltage is 1 volt. Then after we got one value. Clear? So from that P is equal to V VQ by T. So this is the energy transferred. So this has unit joule and this had unit second. So joule per second is also the unit of power. So power has basically joule per second, or it is written as watt. That is this. Clear? So if we want to write 1 watt, then what will be there? That is 1 joule upon 1 second. Clear? So this is written like this. 1 upon 1 is no change, because 1 is 1 by 1 is cancelled, that will become 1 again. So it is 1 watt. Are you getting what I'm saying? Right? So how can we get 1 watt power? So if we talk about this, it means if we apply 1 volt and 1 ampere current is flowing, then the power that will be calculated will become 1. And from this formula of energy transfer, that if 1 joule energy is transferred in 1 second, that will also be 1 watt power. Clear? So this is the unit. What is what? That is the unit of power. So whenever you purchase anything, right? If you purchase computer, kettle, and any appliance, so there will be voltage value, there will be current value, there will be power, right? Everything is mentioned there. So whenever you can we purchase computer, kettle, television, bulb, any appliance for your home, then these power will be mentioned there. Clear? Means this much power will be consumed by your appliance. If we use computer, then 100 watt, approximately 100 watt will be the consumption of the computer. For kettle, it will be 2 kilowatt, right? 2, 3, 5, so many watts are there, right? Depending upon the power that is required for the appliance, right? So similarly for LED television, it is approximately 100 watt. Okay, so in earlier days we used 100-watt bulb, right? Now it is 9 watt LED bulb. So what is the difference? The consumption of power consumption. That is why we have less electric bill. Okay, so we are getting less bill now. Earlier it was higher, but at that time, if we compare the amount, it will be less, because the per unit, the rate was very less at that time, 2 3 rupees. Now it is 10 rupees. So depending upon the value, it is higher now. But if we compare the consumption, it is less now. The government is also promoting the solar panel. So many things are there. So you can put solar panel at your roof, then power will also be generated at your home. Okay. So this is that thing. So we can calculate power, as I told you that I'll give you the example. So how power can be calculated? So what you need actually. So we had three formula. P is equal to VQ upon T, that is Vi, that is I square R, that is V square upon R. So these are the formula. So you can use this one, this one, this one, or this one. So what is the difference? The difference is of the value that we are having, right? We are having, if we have voltage, uh, charge and time, then we can use this first one. If we have voltage and current value, then we can use this one. If we have current and resistance value, then you can use this one. If you have only voltage and resistance value, you can use. So depending upon the sentence that you are reading, you can write the value which is given to you. Then after you can decide which formula is useful for you for calculating power. So as in this statement, in other words, electrical kettle running from 240 volts and consuming 5 amperes. So volt is V. So we will write first that is this. Okay. Consuming 5 amperes, that is the current value, that is 5. So we will write the value which is given. So we have only two values, that is V and I. So which formula can be used? In which formula we have only V and I? Here it is charge, it cannot be used. Here it is V and I both. So we can use second formula. So first we will write the formula P is equal to VI. We will put V 240, I 5. Okay. So what will be there? It will be 1200 watts. So this is the power. This is the answer. Okay. Now solve this. You solve this. I have removed this value. At 415 volts, that is V 415, 5.5 kilowatt power is there. That is P. P is 5.5 kW, that is kilowatt. So whenever you are going to solve any numerical, first thing that should be remembered is convert the value in basic unit. Basic unit means if you have value in kilowatts, convert it into watt, because the formula that we are having is in watts only, right? So how can you do this thing? So as you know, 1 kg is how much grams? 1000 grams, right? So it is actually 10 to the power 3. So 1 K is basically 10 to the power 3 times of the value. Clear? So what we will do? We will replace this K by 10 to the power 3. So 5.5 is written as it is into K will be replaced by 10 to the power, and now it is in watts. So this P will be used for calculating the current. So find out the current value using voltage 415 volts and power 5.5 into 10 to the power 3 watts. All of you will give me the answer. Yes, Meena, it's correct. Yes, so you have you have power and volts value now. So you find out the value of current and give me. Hmm. Has anyone done it? Nobody. Divyajyoti Das is saying 13.25 is what? 13.25 unit. Divyajyoti, where is the unit? Divyesh, what you are calculating? Divyesh, voltage value is already given. Then how could you find the value of voltage? Divyajyoti, where is the unit of 13.25? We need to write just after the value. Okay, Meenal. Thank you. So which formula we will use? We will use the formula P is equal to VI, and from that formula we can find I, that is P upon V. Put the value of P, that is 5.5 into 10 to the power 3 upon 450. Calculated. First, remove the decimal, that is 5,500, that is 5,500 upon 450. Divide it. So you will get 13.25 ampere, right? So you have to write the unit along with the value. So 13.25 is the value and ampere is the unit. So without unit there is no value. There is no importance, right? So in examination you don't write, if you don't write the unit, then half marks will be deducted, okay? It is for everyone. It will not be done by one person, it may be done by many persons. So I am telling you in common, that is yes. Okay, so have you all understood this? How can we calculate the power? Can we proceed? Okay, thank you. Now the Ohm's law, that we already used this formula in earlier examples and topics, but how it is working, right? So this is here. So this is the circuit diagram that we are basically use. This is very basic diagram having one resistance, that is R, and this is the battery, that is of V volts. If we don't have the value, we write in general. We will not write any value. Okay. So in general it is V. V is voltage, right? R is resistance. Whatever the value of resistance and voltage there, we need not to write there. Okay. But after connecting this battery, the current will flow. So what I told you, that current flows from positive. So positive terminal is this, negative is this. Longer is positive, shorter is negative. So current flows from positive to negative like this. So this is flowing clockwise. Okay. So this is the entry. This is the releasing point. So this resistance will also having positive and negative. Entering point will always be positive and relieving will be negative. Okay. So what voltage drop is there? What is the voltage drop? That is, we are providing V volts, but due to this resistance, the current will be resisted, right? It will oppose the flow of current. The resistance is what? That resists the flow of current, right? So current is flowing from this to this. So how much current was resisted by this resistance? Accordingly, we will calculate the voltage drop. So that voltage will be dropped at this resistance, right? So what is the value of voltage drop? So we will not write V here because V is already here. So we will write VR. VR. Okay, what is VR? The voltage across resistance R. Okay, so we will write R in suffix so that we can understand that whether this V is there or this V. So if we write both V, we will be confused. Okay, so to differentiate, we will write R along with it. If you want to write here also, then you can write VB. That is the battery voltage. Okay, it's up to you, right? So generally we write V, so that's why I wrote V only. So what is the voltage across this resistance that can be calculated using Ohm's law? So what Ohm says that if we are continuously applying voltage, so that voltage will be proportional to current. Means we are applying voltage, the current will be flowing there. So it is depending upon the voltage. So it is directly proportional. Proportional means if we are increasing voltage, the current will also increase. Clear? But we have to remove this proportional. So there will be one proportionality constant. So R will be there. So V will become Ri, or we can write IR. So this is the way that the Ohm has developed this formula, and this is very much useful for basic circuits, right? For basic circuits, this is very much useful formula. So you should remember it, and this voltage value should be in volts, current should be in amperes, and the resistance should be in ohms. So if any value is in millivolt, kilovolt, milliampere, microampere, then first convert it into ampere, right? I already told you that convert all the values in basic units, right? Clear? Any problem? Any doubt? Oh, okay, this is okay. Thank you. So we got one formula, V is equal to IR. So what we have? We have V, I, and R, three values. Clear? So out of these three, if you have any two values, you can find the third one, right? So from this formula, you can find V because you have I and R. You can find this. If you have V and R, then you can find I. If you have V and I, you can find R. So you have three formula from this. Clear? It will be upon I. Right? So you can calculate some values. This is the first example. If a voltage of 6 volts, So whenever you calculate, you write the given values first. 6 volts, so you write V is equal to 6 is placed across 140 ohm resistance. Write R is equal to 140 ohms. This is the ohm value. Determine the amount of current. I is needed to be kept. So first you have to recall that V is given, R is given, and you have to find I. So which formula is useful there? Which formula can be used? So V, R, and I. So yes, Ohm's law is there. So Ohm's law formula is V is equal to IR. So that formula will be used here. So from this we calculate, because we have to calculate I. So we will use this formula. So first we will write, since I is equal to V upon R, then we will put this value 6 volts upon R is 140. Calculate it. Okay. So after calculation, it will be this point 0.0429 ampere, right? But this formula seems to be means very typical of not suitable value. Okay, it should be written like 4 point something. Okay, so we can calculate this value in another unit. So what we will do here, we will do that we will shift this decimal from here to here. So it will become 442.9. So you have already studied mathematics. Decimal point, right to left, left to right shifting. So what we are doing, we are shifting from left to right. So how many places it is shifted? It is shifted by 1, 2, 3 value. So it will be 3, but it is from left to right. So this will be negative. Clear? It will be negative. Ampere is ampere. And this 10 power 3. So what I told you, 10 power 3 is kilo and 10 power minus 3 is milli, right? So we can convert or replace this k by 10 power 3, but this 10 power minus 3 can be replaced by milli, that is small m. Small m, not capital. Capital M is mega. So we will replace this 10 power minus 3 by small m, that is milliampere. So this 42.9 will be written as milliampere. Clear? So you are free. You can write 0.0429 ampere or 42.9 milliampere. Okay? So it's up to you. You can use any of the value. Both are correct. Okay? Now do this example yourself, please. Do example 2 yourself. Yes, Meenal. You already wrote this thing? Have you done this example? So it is same example. In this example, you have to find the resistance value R. So in place of this, you will use this third one. third formula. R is equal to V upon I. So what we have? We have voltage value here, 230. We have current value I, and we have to find R. So this formula will be used here. So after putting this value, you will get this. So in place of writing OHM ohm, you should use the symbol. Okay, this is the ohms symbol. Got it? Yes, Meena, it is correct. Shall we proceed? Proceed. Okay, thank you. So what we studied what is electricity, what is electric current, what is electric power. Okay, so we have studied the components, right? But what is the use of all these things? So we are calculating for any given circuit. Okay, so that circuit is electric circuit. So what is electric circuit? So whenever you talk about any circuit, the circuit is nothing but the closed loop, closed path. Okay, if you don't have the electricity at your home, then you call one electrician. So what is the role of electrician? He checks the circuit first. What is in it? He will check whether any circuit is open or not. So open means it is disconnected somewhere. So he wants to find the disconnection in the given circuit. So he will do, he will check through the tester. If current is coming to that point, it means the circuit is completed, and completed means closed. If circuit is not completed, the current will not flow in the whole path. So that path should be closed. It should make one loop, right? So this closed path is the electric circuit. And what is the use of that circuit? So what we are doing, we are actually using those paths for transmitting any electric current. Okay, we have electric current from the source. So that energy, that electric current should be flowing through somewhere. Okay, so that something is the wire, and wire is making the closed path, and that is actually the electric circuit. Okay, so that electric circuit is having the wire, the cable, and that cable is also known as the medium for flowing the current. Clear? Any doubt? And the medium can be of electrical or magnetic field. Magnetic field means if we are flowing the current, then magnetic field will also be there, right? Electric field should also be there. So it will be understood later on. So first you should understand what is electric circuit. So electric circuit is nothing but the closed loop, closed path that is used for transmitting the electric current in the given uh, network. Okay, clear? But what we are using in the electric circuit, what can be the components of the circuit? So first we need the source. If you don't have source, the current will not be generated. If current is not generated, then there is no use of electric circuit, right? So first requirement is the source, that is generating the energy, that is that can be voltage source, that can be current source, that can be battery. Clear? That can be battery. So battery is used as a source, that is here. So battery, cell, anything can be used here. What is the difference between cell and battery? The series connection of more than one cell is known as battery. So single cell is cell only, but the series combination, if we are adding more cells in series, it will become battery. Clear? So first important component is battery. And after this battery, the current will be flowing. So for current flow, the wire is required, the cable is required. So wire can be of copper, aluminum. So basically for higher load, we use copper wire. Okay. And for means normal load, we can use aluminum. Okay. So whenever you go to any electrical shop to purchase any wire, so he will ask you the load, what you want, where do you want to use the wire. If you want to uh, light only one bulb, one fan, he will offer accordingly. But if you say that we will use for heater, right, for electric kettle, okay, so depending upon the load, he will means suggest you that this wire should be purchased. Clear? So for heavy load, we use copper. For light load, that is aluminum can be used. So second required component is wire. Clear? That is this. This is wire. Okay. And wire, cable, whatever. Second is for basic for making basic circuit, we use bulb, lamp. Okay. So this is here, because bulb will tell you whether the circuit is completed or not, it is closed or not, right? What I told you, that if circuit is completed, then current will flow, and if current is flowing through that network, then bulb whatever you are using there will be working. So we want to just see whether the current is flowing or not. So this identification can be done by bulb, LED, whatever you want to use. Clear? So this is it. We have connected. So all these are connected in series, okay, or can be connected in parallel also, depending upon the usage. But this is the series. So this is series combination. Series combination, one after another. We are just adding. But we have used one more component, that is switch. So what is switch? Switch is the component or device that is used to connect or disconnect the network. Connect, disconnect means if you permanently connect the wire, like fan at your home, bulb, anything, so it will be continuously working. But at some time or during some time you want to switch off. So what? How can you connect, disconnect it? You will cut the wire. This is the only way, that you cut the wire every time. If you want to restart it, again connect the wire. So it is not possible for us to do the same thing again and again. So we are using the switch. So switch is the component or device that is used to connect and disconnect. Okay, complete or incomplete the circuit. Okay, so this is it. So you want to switch on the fan, you just go to the switch and on it. Clear? You don't want to use the fan, you switch off it. Okay, so it is very easy task in place of cutting and connecting again. Okay, so we are using switch for the same. So these are the basic components for making a very basic circuit. And whenever you connect this switch, the circuit will be completed like this. Current is flowing through this here, and bulb will glow, and you will understand that current is flowing here, and current is circuit is completed. Got it? Any doubt? Have you understood? Okay, Divijay. Thank you, Meenal. Thank you. Thank you, Mahendra. So what is actually going there in the circuit? So as I told you that circuit is flowing, or current is flowing. So what is that? That is actually the flow of electrons. Circuit is flowing, current is flowing, that is flow of electron is there. So those electrons are flowing through the path, that is the closed path, and that path is induced by EMF. What is EMF? Electromotive force. Okay, electromotive force is what? That is the voltage value, volts in volts of battery, without connecting any circuit along with it. Okay, so this is actually generated by external source. So this external source is creating electric current. Okay, and these electrons which are flowing through the circuit leave a path through a load. So load is what? So this lamp, the current which is flowing in the circuit is consumed by lamp. Who is using this electric current? This lamp, this bulb. Okay, so this lamp is treated as load. Clear? Clear? So this lamp is consuming. So load is basically using this current, this flow of electron. Clear? And whenever we talk about any circuit, there will be ground or earth also. Yeah. So whenever suppose this is the circuit, so this one line will also be grounded. So this ground or earth is also used there, and this is completing the closed path. This is basically used in if we use analog source, right? Like voltage source or current source. Clear? So one line, if we talk about any network, so this is positive, this is negative. So this negative is always grounded, and this ground is actually making the circuit. It is completing the circuit. Okay, like this. If this cell is there, so current will flow positive to negative. This is positive to negative. So this positive to negative. So if this is not connected, the circuit will not be completed. Clear? Similarly, in any circuit, any voltage source, any which we are using any circuit, then ground or earth should be there. So it is showing like this. If it is not there, the circuit will not be completed and the current will not be flowing there. Okay, so this ground is completing a closed path or circuit. Okay, and load can be lamp, bulb, LED, laptop, okay, heater, anything. Whatever you are using with the circuit, we are connecting with the circuit is the load, which is consuming the energy. I hope you understood this thing. No, no, Earth is not conductor. Earth is not conductor. Earth is actually completing. It is treated as the negative part of the circuit. Okay, so whenever the current flows from positive to negative, so whenever you want to complete circuit, you earth the wire. So earth is actually completing the circuit. It is treated as negative. Okay, okay, Minal. Okay. So in any given circuit, right? We used wire, we used source, that is battery, can be any generator also. Okay, we used switch, we used load, Okay, so what type of elements we are using in any of the circuit? Okay, so in any of the circuit, we have two types of elements, active or passive. The elements that you are using in any circuit are classified into two, that is active elements and passive elements. So what is active element or passive element? How can we differentiate it? So these are here, that is, if active means which are generating the energy. Okay, like battery. So battery is generating. Okay, it is not consuming, it is not taking something. Generator. So generator is what? That generates something. So we are having generator that is generating the energy and providing to the circuit. So in any of the circuit, we will have this type of active element because it is required. Without energy, there will not be use of any network, and energy is generated by the battery or generator. Okay, so it is providing the energy, and these type of elements can be classified into further classified into two, that is dependent and independent source. Dependent independent is it can be dependent on something or independent of everything. It is not depending upon anything of the circuit. Okay, so battery source is actually independent source because it is providing the energy, that can be voltage, without dependency on any of the other thing. So it is providing the constant voltage. If you have seen the voltage or at your home, if we have uh, inverter, right? So if we have charged battery, then we are continuously using it, and suddenly it becomes off. Why? Because it either provides constant voltage, so we are using properly, but suddenly it becomes zero and the power is cut, completely cut. It will not vary like low, 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 low. No, it will not be lowing. It will be directly low to the zero value. Okay, so it is providing constant. So it is not depending upon whether you are using one bulb or two bulb. Not doesn't matter. It will be directly off. Okay, and on other hand, transistor provides current depending on voltage applied. So we will study transistor. Okay, transistor are PN, PN, and PN. So it provides current depending on voltage applied. Okay, like if we are applying lower voltage, it will be having lower current. I told you in Ohm's law. Lower voltage value, lower current. Higher voltage value, higher current. So it is depending actually. The current value is depending upon the applied voltage value. So if we are applying low value of voltage, then we will have less current, right? So depending, there is dependency. So it is providing the dependent source. And if we talk about the passive elements, so passive elements means that can consume something, that can resist the current. Okay, so those are passive elements. So these elements are actually controlling the current, that is controlling the flow of electrons which are flowing through the circuit. Okay, it can either increase or decrease the volume, so depending, like resistance. So resistance can have low value across it, higher value depending upon its value. V is equal to IR. So if you are having less R, less voltage. High R, high voltage, because I into R, I is constant, R is increase or decrease, accordingly we will have low or high voltage value. Okay, so we have used resistor, we will use capacitor and inductor also. These are also the component. So these are passive components. Okay, passive elements that are also used in many of the circuits. So this is the classification of the elements that we are using in electric circuit. So I hope you understood all these things. I already discussed in between. So still you have any doubt, you can ask me. Thank you, Devvijay. Any doubt to anyone, you can ask. Yes, sir. Sorry. Okay, Rahul, thank you so much. Any one of you, any other student that has any doubt, you can ask me from today's session or previous session, you can ask me. You are free to ask anything if time permits. Okay, time should also be there. Okay, Divya. So many students are there, but asking very less students. So I think we should end the session. Okay. So we will meet in the next session with a new topic. Okay. And also come with your doubts because I start with the doubt first, then start the session. Again, doubts in the end of the session. So you have sufficient time for asking any doubt. Okay. So if still you have any doubt, you can ask me next time. No problem. Okay. Minal, actually, yes, I'll try. I will remove the answer or hide the answer. Okay. Sure. Thank you. Okay. So thank you so much. Happy learning. Thank you and take care. Thank you. Bye bye. You can leave the session and come for the next class that is at 6:30.